In the vast tapestry of Earth's geological history, volcanoes stand as both creators and destroyers, shaping landscapes and civilizations alike. Imagine a fire-breathing giant, awakening from its slumber after centuries, reminding humanity of its precarious place on this planet. As we delve into the world of volcanoes that could end civilization, we find ourselves at the mercy of these formidable natural forces. Around the globe, there are over 1,500 active volcanoes, each possessing unique characteristics that can spell disaster. Among these fiery giants, supervolcanoes stand out due to their explosive potential and catastrophic consequences. Supervolcanoes are defined by their ability to produce eruptions in excess of 1,000 cubic kilometers of material, dwarfing typical volcanic eruptions. The Yellowstone supervolcano in the United States is perhaps the most famous of these titans. Since its last cataclysmic eruption approximately 640,000 years ago, scientists have been closely monitoring its activity. This enormous caldera, which measures around 30 by 45 miles, holds enough magma to cover the entire continental United States with ash. Understanding the dangers posed by Yellowstone requires delving into its past. On that fateful day, the eruption sent up to 1,000 cubic kilometers of volcanic material high into the atmosphere, leading to a volcanic winter that disrupted climate patterns and agricultural systems across the globe. Such an event would spell doom for modern civilization, given our reliance on stable climates for food production. But Yellowstone isn't alone. The Toba supervolcano in Indonesia is another harbinger of potential doom. Approximately 74,000 years ago, Toba erupted, creating one of the largest eruptions in Earth's history. The cataclysm released an estimated 2,800 cubic kilometers of material, leading to a volcanic winter that is believed to have caused a drastic reduction in the human population. It's theorized that this eruption caused a bottleneck in human evolution, bringing humanity to the brink of extinction. Toba's eruption released vast amounts of volcanic gases into the atmosphere, affecting global temperatures and sunlight, resulting in a prolonged period of cold and darkness. Scientists suggest that such an eruption today could lead to similar catastrophic effects, disrupted agriculture, threatened ecosystems, and widespread starvation. Acknowledging the reality of such explosive events is vital. Around the world, scientists are engaged in the critical task of monitoring these volcanoes to predict when the next catastrophic eruption might occur. Advances in technology now allow geologists to assess volcanic activity through seismic monitoring and gas emission analysis, transforming our understanding of these natural titans. However, many questions remain unanswered. As we ponder the implications of supervolcano eruptions, we realize that understanding their nature is crucial for our survival. What happens when the Earth's fire breathes once again? Could civilization endure the heat of destruction? The impact of volcanic eruptions transcends mere destruction. They have far-reaching consequences that ripple through ecosystems and human societies. When a volcano erupts, it doesn't just release magma, it spews out ash, gases, and pyroclastic flows that can decimate everything in their path. This chapter dives into the chilling effects of significant eruptions through history and the lessons learned. One tragic example is the eruption of Mount Vesuvius in 79 AD. This infamous eruption buried the Roman city of Pompeii under 4 to 6 meters of volcanic ash, preserving the city for centuries. Thousands perished as Vesuvius unleashed its fury, showcasing the devastating power of volcanic eruptions on urban life. The ash rained down relentlessly, smothering the city and creating a time capsule of Roman life. In contrast to Vesuvius, the eruption of the Krakatoa volcano in 1883 set the stage for understanding the global reach of volcanic eruptions. The explosion was so loud that it was heard over 3,000 miles away, and its effects were felt worldwide. It ejected enormous quantities of ash into the stratosphere, causing a drop in global temperatures by up to 1.2 degrees Celsius. This led to what is known as the Year Without a Summer in 1884, resulting in crop failures and food shortages as far away as Europe and North America. It's a harrowing reminder that an eruption in one part of the world can have devastating effects thousands of miles away. The 1980 eruption of Mount St. Helens in Washington state provides another case study revealing the various impacts of volcanic activity. It exploded on May 18, 1980, causing the deadliest volcanic eruption in U.S. history. The eruption reduced the height of the mountain by over 400 meters, transforming the landscape forever. The event released an enormous volume of volcanic material, decimating an area of 600 square kilometers. The aftermath saw a significant loss of wildlife, as well as long-lasting changes to the region's ecology. Examining these events teaches us about the intricate relationship between volcanoes and climate. Volcanic eruptions emit vast amounts of sulfur dioxide, which turns into sulfate aerosols in the atmosphere, reflecting sunlight and altering climate patterns. For instance, the eruptions in the 1991 of Mount Pinatubo in the Philippines demonstrated this effect. It led to global cooling for about 2 years and disrupted weather patterns globally. Such changes can threaten food supply chains and agricultural stability. As we learn from historical eruptions, it's evident that preparation is crucial. Governments worldwide are investing in eruption prediction technology, emergency plans, and community education to mitigate the risks. Yet, how effective are we at handling such potential disasters? As we look into the future, we must confront the reality that another catastrophic eruption is inevitable. With millions living near active volcanoes, understanding the depth of their impact is more critical than ever. What lessons will we learn before the next eruption strikes? To truly understand the potential hazards posed by volcanoes, we must delve into the science behind their eruptions. The mechanics of how magma rises to the surface and ultimately erupts is a complex interplay of geology and pressure. At the heart of it all lies the movement of tectonic plates. The Earth's crust is divided into massive plates that float on the semi-fluid mantle below. When these plates interact, they can create rifts, subduction zones, and boundaries that are ripe for volcanic activity. Subduction zones, where one plate dives beneath another, are particularly prone to forming volcanoes. The pressure of the sinking plate melts rock, generating magma that can rise to the surface. Consider the Pacific Ring of Fire, an area encircling the Pacific Ocean teeming with volcanic activity. It is a prime example of the relationship between plate tectonics and volcanism. The ring is home to over 75% of the world's active and dormant volcanoes. This geographic connection illustrates how the movement of tectonic plates can lead to potentially catastrophic eruptions. In addition to tectonic movements, pressure buildup within a volcano plays a significant role in determining how and when an eruption will occur. As magma rises, gases dissolve within it until they reach a critical point as pressure decreases near the surface. Increased pressure can lead to explosive eruptions, releasing energy akin to nuclear bombs. Volcanologists use various tools to measure these pressures and gas emissions. Seismographs detect tremors as magma moves underground, while gas analyzers and thermal imaging can give insights into a volcano's state. These technologies have advanced in recent years, increasing our ability to predict eruptions with some accuracy. However, predicting the exact moment of an eruption remains a challenge. Just because a volcano is rumbling doesn't guarantee it will erupt imminently. Therefore, researchers must have a comprehensive understanding of geological history to assess underlying risks. This historical context is critical. Not all eruptions are the same, and geological patterns can vary dramatically. For instance, the eruption of Mount St. Helens in 1980 was preceded by weeks of seismic activity. Scientists who monitored the volcano were able to issue warnings, allowing many residents to evacuate in time. Yet, other eruptions have caught communities off guard. The devastating eruption of Mount Nyiragongo in 2002, which occurred with little forewarning, exemplifies this unpredictability. A lava flow cascaded into the nearby city of Goma, resulting in over 100 deaths and displacing thousands. As we continue to improve our understanding of volcanic science and develop predictive tools, we must also recognize the inherent unpredictability of these natural events. Each eruption holds the potential to provide insights that could save lives, but they also remind us of our vulnerability in the face of nature. Will we be prepared when the next eruption occurs? Only time will tell. But one thing is certain, the more we learn, the better equipped we become to face the fiery giants of our planet. Looking through the annals of history, we find numerous examples of volcanic eruptions that have left an indelible mark on human civilization. Each event unfolds a narrative of destruction and resilience, revealing how these natural disasters have shaped societies across the globe. One of the most notorious eruptions in history is the eruption of Mount Vesuvius in AD 79, which buried the towns of Pompeii and Herculaneum. The suddenness of the eruption caught many residents unaware, leading to the loss of thousands of lives and the preservation of their final moments in time. The account of Pliny the Younger, who witnessed the disaster, serves as a testament to the power and unpredictability of volcanoes. His letters describe a cloud of ash and pumice rising into the sky, and he eloquently details the chaos that followed. The eruption of Krakatoa in 1883 demonstrated that the effects of a volcanic eruption can transcend the immediate area, affecting global climate and society while triggering tsunamis that devastated coastal communities. This eruption produced the loudest sound recorded in history and resulted in climate anomalies around the world. Researchers estimate that more than 36,000 people died as a result of the eruption, with many more impacted by the ensuing climatic changes. In a more recent context, the eruption of Mount St. Helens in 1980 serves as a stark reminder of the transformative power of volcanoes. This eruption altered the landscape, created new geological formations, and served as a case study for scientists worldwide. The event led to extensive research on volcanic eruptions and initiated a greater focus on disaster preparedness. From these historical examples, we learn not just about the volcanic processes, but also about the human response to such disasters. Communities across history have had to grapple with the aftermath, reconstructing their lives, economies, and cultures. The resilience exhibited by survivors in the wake of destruction is a powerful testament to humanity's capacity to recover. As we reflect on these stories, we must also confront the reality of our modern world. With billions living in the shadow of volcanoes, what lessons can we glean from the past? The stories of Pompeii, Krakatoa, and St. Helens should serve as warnings but also as reminders of the possibilities for human ingenuity and resilience. We must prepare not just for the destruction, but also for rebuilding and recovery. In navigating the challenges posed by volcanic eruptions, we have the opportunity to create systems in place to protect lives while preserving our cultural and historical legacies. With a blend of science, preparedness, and community engagement, we can forge a path towards a safer future. In our quest to mitigate the dangers posed by volcanoes, modern science has developed an array of monitoring systems and safety measures designed to protect communities at risk. As we face the inevitable reality of future eruptions, understanding these technologies becomes paramount. Today, volcanic monitoring relies on a combination of ground-based and satellite technologies. Seismographs play an essential role in detecting tremors and vibrations in the Earth's crust. These vibrations often indicate the movement of magma, allowing scientists to assess a volcano's potential for eruption. The data collected by these instruments feeds into early warning systems that alert local authorities and residents to potential dangers. In addition to seismology, scientists utilize remote sensing technology, such as satellite imagery, to monitor heat emissions and changes in volcanic landscapes. These advances have greatly improved our ability to predict volcanic activity and respond to eruptions. For example, researchers can analyze thermal anomalies to identify unusual activity in a volcano's magma chamber, signaling possible eruptions days or even weeks in advance. While predicting eruptions with absolute certainty remains elusive, the science of volcano monitoring continues to improve. In areas at high risk of volcanic activity, communities are increasingly building resilience through education and preparedness programs. Schools, local government, and organizations work together to train residents in evacuation procedures and emergency management strategies. These initiatives empower people to respond swiftly and effectively when an eruption occurs, mitigating the chaos that often accompanies disasters. Real-life examples of successful evacuation plans highlight the importance of preparedness. During the 2014 eruption of Mount Sinabung in Indonesia, timely warnings allowed thousands of residents to evacuate safely, saving countless lives. This proactive approach demonstrated the potential for communities to adapt to the reality of living in volcanic regions. Yet, not all situations yield such positive outcomes. The unpredictability of eruptions, as seen in the case of Mount Nyiragongo in 2002, emphasizes that not every community will have advance warning. Rapid response measures, including emergency shelters and medical aid, must be in place to protect those in harm's way. Collaborative efforts among governments, scientists, and local communities are key to effective disaster management. Looking to the future, we can only hope that our understanding of volcanoes continues to advance alongside technology. By fostering collaboration and communication between researchers and communities, we can build a comprehensive framework for disaster preparedness. As we learn from the past, we can create safer spaces and develop resilience against the unpredictable forces of nature. As we conclude this chapter, we must reflect on the balance between living in harmony with nature while also recognizing its power. With appropriate measures in place, we can continue to thrive alongside these fiery giants, ready to face whatever challenges they may pose. Imagine a volcano so powerful, its eruption could blanket the earth in ash and make large areas uninhabitable for years. Welcome to the world of supervolcanoes. A supervolcano is defined not by its height, but by its ability to produce massive eruptions with a volcanic explosivity index of 8, the highest level possible. The Yellowstone caldera in the United States is perhaps the most infamous example. This massive volcanic system has erupted 3 times in the last 2 million years, with the last significant eruption occurring approximately 640,000 years ago. The ash fallout from such an eruption would be catastrophic, affecting agriculture, air travel, and public health across vast regions. Beyond Yellowstone, the Taupo volcanic zone in New Zealand presents another chilling example. Its most recent major eruption, around 232 AD, called the Hatapi eruption, is believed to have released around 100 cubic kilometers of material into the atmosphere. This event significantly impacted the climate, leading to what scientists suspect was a volcanic winter. The supervolcano's potential for widespread destruction lies in the fact that they can erupt with little or no warning, presenting substantial challenges for monitoring efforts. Understanding these giants is crucial as scientists utilize a variety of techniques to predict their behavior. Seismic activity, ground deformation, and gas emissions are all indicators of potential eruptions. Yet, despite improvements in monitoring, experts are still unable to pinpoint the exact timing of an eruption, an unsettling reality that leaves society in a precarious position. The frequency and magnitude of supervolcano eruptions present a ticking clock for humanity. What would happen if a supervolcano erupted today? The ash fallout could lead to severe agricultural failures, food shortages, and subsequent civil unrest globally. History has shown us the consequences of such natural disasters. The Toba supervolcano in Indonesia is estimated to have erupted around 74,000 years ago, reducing the human population drastically and leading to a genetic bottleneck. This event serves as a reminder of how quickly supervolcanoes can change the course of human history. These monstrous formations are more than geological oddities, they are reminders of nature's raw power. As experts continually study these giants, one question looms: how prepared is humanity for a potential supereruption? The answer may determine not just local communities' survival, but the fate of civilization itself. Volcanic eruptions don't just bring chaos to the natural world, they can also devastate economies. The financial implications can be staggering, as eruptions disrupt supply chains, agriculture, and tourism. Take the 2010 eruption of Eyjafjallajökull in Iceland as a striking example. The ash plume from the eruption grounded flights across Europe for several weeks, affecting over 10 million passengers. The economic impact was estimated at around $5 billion, highlighting just how interconnected our world has become. Beyond travel disruptions, eruptions significantly impact local economies reliant on agriculture. Following an eruption, ash can render farmland unusable, leading to crop failures that may last for years. For instance, in 1985, the Nevado del Ruiz eruption in Colombia resulted in the tragic Armero tragedy, where Lajar's volcanic mudflows left thousands dead and rendered agricultural land unusable. The long-term economic repercussions of this event were felt for generations, with local farmers struggling to regain their livelihoods. The tourism industry also faces considerable losses during and after an eruption. Regions famous for their natural beauty often rely on tourism for economic stability. When Mount St. Helens erupted in 1980, the immediate impact on tourism was severe, leading to a sharp decline in visitor numbers to the region. Although nature eventually reclaimed the land, it took years for the tourism sector to recover fully. The events surrounding this eruption illustrate how reliant economies are on steady tourist flows and how quickly natural disasters can alter economic landscapes. Moreover, the psychological impact on communities must not be overlooked. Fear of potential eruptions can lead to decreased property values and a reluctance to invest in local communities, further exacerbating economic hardships. With our global economy becoming increasingly fragile, understanding the intricate relationship between volcanic activity and economic stability is imperative for future planning. How will we mitigate these risks as we advance? The interplay between nature and economy presents a complex challenge as we continue to grapple with volcanic hazards and their cascading effects on society. As history teaches us, preparation and resilience will be key to weathering future eruptions. As volcanic threats loom large, the global community is not standing idly by. In recent years, collaboration between scientists, governments, and organizations has become crucial in mitigating the risks posed by eruptions. Knowledge-sharing agreements and initiatives foster a more unified response to volcanic crises on an international scale. Organizations like the International Association of Volcanology and Chemistry of the Earth's Interior, IFCI, play a vital role in this collaborative framework. Technological advancements have paved the way for enhanced monitoring systems that are paramount for early warning systems. For example, satellite technology enables scientists to detect thermal anomalies that might suggest increased volcanic activity. Data collected through these advanced means allows for more timely evacuations and resource allocations, potentially saving countless lives. Furthermore, education is an essential component of the global response. Communities living near active volcanoes need to be informed about risks and emergency procedures. In many regions, local governments are now implementing disaster preparedness programs that include regular drills and evacuation plans, aiming to cultivate a culture of safety. Such proactive measures can make a significant difference in saving lives during an eruption. However, despite these advancements, challenges persist. Not all countries have the resources or technology to effectively monitor their volcanic threats. In places like the Democratic Republic of Congo, the active Nyiragongo volcano poses a significant risk to nearby communities. Though local scientists have made strides in understanding its behavior, inadequate funding and support limit their ability to develop comprehensive monitoring systems. Addressing these disparities is essential in the global response to volcanic threats. The formation of international task forces to provide technical assistance and funding to vulnerable regions could prove invaluable. As our world becomes more interconnected, the urgency to collaborate on these pressing issues grows. The question remains, can humanity unite in the face of such natural disasters? Volcanoes have long inspired stories, myths, and legends throughout history. From ancient civilizations to modern cultures, humanity has woven narratives around these mighty natural phenomena. Yet, some of these tales perpetuate misconceptions that can cloud our understanding of volcanic activities. One of the most pervasive myths is that volcanic eruptions can predict earthquakes. While it's true that both phenomena are related to tectonic plate movements, one does not cause the other directly. Another common misunderstanding is the idea that eruptions are solely destructive. While volcanic eruptions can be catastrophic, they can also produce fertile land and essential minerals. The eruption of Kilauea in Hawaii has created new land and lush ecosystems, illustrating how nature reclaims and revitalizes itself. The balance between destruction and creation is an intricate dance that defines our Earth's geology. Moreover, the portrayal of volcanoes in media often exaggerates their dangers. Films depict dramatic eruptions that could only happen in a perfect storm of conditions. Such dramatizations can lead to a culture of fear that may hinder practical responses when real threats arise. Rather than instilling fear, understanding the science behind these forces can empower communities. Then there's the myth that once a volcano has erupted, it won't pose a threat again. This misconception is particularly dangerous. Mount St. Helens was once thought to be dormant before its significant eruption in 1980, reminding us that nature's slumber can be deceiving. Ongoing monitoring is crucial, as eruptions can reawaken volcanoes thought to be extinct or dormant for centuries. Understanding these myths and realities is essential for informed decision-making. As communities grapple with living in the shadows of these geological wonders, knowledge becomes the most powerful tool in mitigating risk. As we separate fact from fiction, what deeper understanding will emerge about our planet's fiery heart? As we face the challenges posed by volcanoes, it is essential to focus on resilience and preparedness. The question we must ask ourselves is, how can we, as a civilization, learn to coexist with these powerful natural forces? Education and awareness are at the forefront of building resilient communities. Programs aimed at informing residents in volcanic-prone areas about risks, preparedness strategies, and response plans can save countless lives. Moreover, governments need to prioritize investment in infrastructure capable of withstanding volcanic impacts. From robust evacuation routes to buildings designed with volcanic resilience in mind, the infrastructure we build today can save lives tomorrow. The tragedies of the past must inform our actions moving forward. Technological innovations will also play a vital role in our preparedness efforts. As monitoring systems improve, so too will our ability to respond effectively to potential threats. Innovations in early warning systems can provide communities with critical information, allowing for timely evacuations and resource distribution. The future of our relationship with volcanoes lies in collaboration between governments, scientists, and the public. Initiatives that promote community engagement in monitoring efforts can empower individuals to take part in their safety. Furthermore, partnerships between nations can establish a unified front against the threats posed by volcanoes, sharing resources and knowledge to bolster global resilience. As we conclude our exploration of the volcanoes that could end civilization, it is clear that knowledge and preparedness are our greatest allies. The more we understand, the better equipped we will be to face the challenges ahead. As we look towards an uncertain future, the story of humanity's resilience stands strong. Let's wonder together, can we transform our fears into actions that will ensure our survival? The Earth's climate is a complex system influenced by numerous factors, and one of the most significant among them is volcanic activity. Each year, volcanoes spew millions of tons of ash and gases into the atmosphere, and this phenomenon can have a profound impact on global temperatures. When Mount Pinatubo erupted in 1991, it released an enormous cloud of sulfur dioxide into the stratosphere. This cloud reflected sunlight and caused global temperatures to drop by about half a degree Celsius for 2 years. Imagine if a supereruption like the one at Yellowstone occurred. Geologists estimate that such an event could inject massive amounts of particulates into the atmosphere, potentially leading to a volcanic winter. Research indicates that major eruptions in the past have altered climate conditions for years. One notable example is the eruption of Krakatoa in 1883, which not only killed tens of thousands but also significantly impacted weather patterns across the globe for several years. The ash and sulfurous gases emitted from the eruption altered rainfall patterns, causing droughts in some regions and intense storms in others. The lesson here is clear: the effects of volcanic eruptions extend far beyond the immediate vicinity. Moreover, the relationship between volcanoes and climate change is not one-sided. As the climate warms due to human activity, the potential for volcanic eruptions could also increase. Melting ice caps and rising sea levels can lead to increased geological activity. For instance, the ice covering Iceland plays a critical role in regulating volcanic activity there. This delicate balance means that as we continue to change the climate, we may inadvertently increase the likelihood of eruptions. It raises a daunting question: could our actions lead to a cascade of volcanic activity that threatens civilization? If we do not mitigate climate change, could we also be triggering volcanoes that are waiting for their moment to erupt? The link between these two natural forces is a reminder of how interconnected our planet's systems really are. Understanding this relationship is key to predicting future risks and preparing for them. So, how do scientists monitor these complex systems to provide warnings? As we explore the connection between volcanic eruptions and climate change, we also see the need for global cooperation. No single nation can tackle the immense challenges posed by climate change or volcanic threats alone. It requires a concerted global effort to study and understand these systems, share data, and develop strategies to protect humanity from the potential devastation of volcanic eruptions exacerbated by climate change. As we dive deeper into this relationship, we uncover the urgent need to act now. Can we change our course before it's too late? What steps can be taken to mitigate these risks? The future of our civilization may very well depend on our understanding of these natural phenomena and our ability to adapt to the challenges they present. In the next chapter, we will further explore how technological advancements in monitoring volcanoes can help us predict their eruptions and minimize risks to society. Throughout history, human civilizations have had complex relationships with volcanoes, often viewing them through the lens of spirituality and mythology. Ancient societies were deeply influenced by the volcanic landscapes around them, which shaped their cultural narratives, religious beliefs, and even their daily lives. Take, for instance, the ancient Romans. The eruption of Mount Vesuvius in 79 AD not only destroyed the towns of Pompeii and Herculaneum but also became a powerful symbol in Roman literature and art. The tragedy of Pompeii speaks to how this catastrophic event captured the imagination of poets and historians alike. In the years following, it served as a cautionary tale about the wrath of nature. The very term Pompeii has come to signify sudden destruction, a moment when everything is turned upside down. In many indigenous cultures, volcanoes are seen as sacred entities that embody the spirits of ancestors. In Hawaiian culture, for example, the goddess Pele is revered as the deity of fire and volcanoes. Her destructive powers are not only feared but also respected, as they are seen as a necessary force of renewal and transformation. These cultural interpretations serve a vital purpose. They provide communities with a framework for understanding natural disasters and coping with their aftermath. Stories of gods causing eruptions or myths of creation explain the seemingly senseless power of nature and give people a sense of control in the face of chaos. Moreover, the response to volcanic eruptions has evolved with society. Modern technology allows us to predict eruptions with greater accuracy, yet the fear and awe inspired by volcanoes remain. The eruption of Mount St. Helens in 1980 became a pivotal moment in geological monitoring, but it also triggered a cultural response. Art, literature, and film began to explore the themes of destruction and rebirth through volcanic events. As society grapples with the present and future risks posed by volcanoes, the interplay of culture and nature becomes increasingly apparent. How do we balance our respect for these majestic forces with the need for preparedness? This cultural dialogue can help shape policies around land use, tourism, and emergency readiness. Through examining how different cultures have responded to volcanic threats, we gain insights into the human experience itself. Will we continue to view volcanoes as mere hazards, or can we learn to appreciate them as part of a larger narrative about our connection to the Earth? As we dive deeper, we will uncover how modern societies continue to shape their narratives around volcanoes and how these stories influence our understanding of risk and resilience. What role does storytelling play in our scientific understanding? Are we, too, crafting myths around the science of eruptions? As we stand on the precipice of scientific advancement, the ability to predict volcanic eruptions is becoming increasingly sophisticated. With the integration of technology and data analytics, scientists can now analyze patterns and signals that might indicate an impending eruption. One of the most promising tools in volcano monitoring is satellite imagery. Satellites can capture real-time data on ground deformation, gas emissions, and thermal activity. By tracking these changes, geologists can identify possible eruption precursors and issue timely warnings. But while technology has greatly improved our understanding of volcanoes, predicting eruptions is still fraught with challenges. Volcanoes are complex systems influenced by numerous factors, and not every eruption follows a predictable pattern. In 2010, for example, the eruption of Eyjafjallajökull in Iceland caught the world by surprise, as it erupted with little warning. The ash cloud from Eyjafjallajökull disrupted air travel across Europe for weeks, causing billions in economic losses. This event highlighted the need for continuous investment in volcano monitoring and research. It also raised questions about how societies can prepare for unexpected eruptions. In addition to technological advancements, community involvement plays a crucial role in disaster preparedness. Local knowledge and historical data significantly contribute to understanding the risks associated with specific volcanoes. Engaging communities in monitoring efforts can enhance both awareness and resilience. This approach fosters trust and ensures that local voices are heard in the decision-making process. As we look to the future, we must consider the balance between scientific advancements and human factors. How do we ensure that technology serves communities most at risk from volcanic eruptions? It's a question of ethics, accessibility, and communication. Moreover, global cooperation is essential for monitoring volcanoes on a broader scale. Eruptions do not respect borders, and a volcanic disaster in one country can have far-reaching effects. The international community must share data, resources, and expertise to address these challenges collectively. As we conclude this exploration of future volcanic threats, we are left pondering the delicate balance between nature's power and human innovation. Will we be prepared for the next eruption that could alter the fabric of civilization? It is a challenge that requires not only scientific understanding but also a commitment to community engagement and global cooperation. The future may be uncertain, but one thing is clear: humanity's resilience depends on how well we can predict and prepare for the forces of nature that could reshape our world. The connection between volcanoes and climate change is intricate and vital. Historically, significant volcanic eruptions have resulted in drastic shifts in the climate, affecting global temperatures and weather patterns. For instance, the eruption of Mount Tambora in 1815 led to what was known as the Year Without a Summer in 1816. This catastrophic event resulted in widespread crop failures and food shortages across the Northern Hemisphere. But how do volcanoes influence climate on such a grand scale? The answer lies in the massive amounts of ash and sulfur dioxide they release into the atmosphere during an eruption. These particles can reflect sunlight away from the Earth, leading to temporary cooling. Research shows that large eruptions can decrease global temperatures by as much as 0.5 degrees Celsius for years at a time. Moreover, the implications of this are far-reaching. As the climate changes due to human activity, the potential for volcanic eruptions to affect weather patterns intensifies. One particularly alarming aspect of this relationship is the potential for feedback loops. For example, as glaciers melt due to climate change, they can destabilize the ground beneath them, leading to volcanic activity. This was observed in Iceland, where melting glaciers have triggered increased volcanic activity in recent decades. Scientists predict that as the planet warms, we may witness increased frequency and intensity of volcanic eruptions. To understand these connections better, we can look at the example of the Yellowstone supervolcano. Located in the United States, this massive caldera is not only a natural wonder but also a significant geological threat. Some researchers believe that if the supervolcano were to erupt, the resultant ash clouds could have global climatic impacts similar to those of Mount Tambora, potentially leading to widespread famine and societal disruption. So, as we navigate the challenges of climate change, understanding our planet's volcanic systems becomes critically important. This delicate relationship between volcanoes and climate is not just a scientific curiosity. It represents a ticking clock as we face the dual threats of rising temperatures and potential volcanic activity. Not only must we prepare for volcanic eruptions, but we must also understand how our actions are influencing the Earth's geological processes. The future of humanity hinges on our ability to adapt and prepare for the unforeseen consequences that come from the ever-changing relationship between volcanoes and climate. As we move forward, the challenge lies in bridging the knowledge of these natural phenomena with proactive strategies that can mitigate their devastating impacts. This leads us to ponder: what lessons can we gather from history, and how can they inform our preparation for future volcanic threats? Throughout history, volcanoes have not only shaped landscapes but also cultures. The awe-inspiring yet terrifying power of these geological giants has influenced art, religion, and societal structure across civilizations. From the ancient Romans to modern-day cultures, volcanoes have left an indelible mark on human imagination and mythology. Take Mount Vesuvius, for instance. Its eruption in 79 AD famously buried the Roman cities of Pompeii and Herculaneum, preserving them under layers of ash. This catastrophic event has been immortalized in art and literature, serving as a powerful reminder of nature's might. In this way, Vesuvius became not only a scientific subject but also a cultural icon. Artists and writers have drawn inspiration from these events, creating works that reflect humanity's relationship with nature. In many cultures, volcanoes are seen as sacred entities. For the indigenous peoples of Hawaii, Kilauea is a living goddess, Pele. The eruptions are not just geological occurrences, they are manifestations of divine activity, influencing rituals, stories, and community beliefs. This reverence demonstrates how volcanic activity can intertwine with spirituality and cultural identity. In Japan, the iconic Mount Fuji holds similar significance. Not just a natural wonder, it has been the subject of countless paintings and poems, symbolizing beauty and resilience. The annual festivals celebrating the mountain reflect a collective acknowledgement of its power, showcasing how society can honor nature while simultaneously living in its shadow. Conversely, the fear surrounding volcanic eruptions has led to myths designed to explain and rationalize these natural phenomena. For example, many cultures have tales of deities angered by human actions, leading to volcanic eruptions as a form of divine retribution. These stories serve to educate communities about the dangers of volcanic activity while reinforcing moral and ethical behavior. The narrative of nature punishing humanity is a common theme, used to impart lessons across generations. As the modern world grapples with threats posed by volcanoes, the cultural narratives surrounding eruptions continue to evolve. Social media has allowed these tales to reach a broader audience, transforming ancient myths into contemporary discussions about natural disasters and climate change. This interconnectedness of mythology and science raises questions about how we can learn from history to face modern challenges. Ultimately, understanding the cultural responses to volcanic activity offers insights into how societies perceive and adapt to natural disasters. The resilience shown by communities in the face of volcanic threats highlights a deep-seated connection between humanity and the Earth. As we look toward the future, we must ask, how can we integrate these cultural narratives with modern scientific understanding to foster resilience and preparedness? As we stand at the precipice of scientific advancement, the ability to predict volcanic eruptions remains an elusive goal. Despite the progress made in understanding volcanology, the unpredictable nature of these geological phenomena poses significant challenges. The consequences of a catastrophic eruption could be devastating, leading to widespread destruction and the potential end of civilization as we know it. Understanding the precursors to volcanic eruptions is crucial. Scientists study gas emissions, seismic activity, and ground deformation to gauge the likelihood of an impending eruption. Volcanoes such as Kilauea or Mount St. Helens serve as case studies in monitoring efforts, offering valuable data about the signs preceding an eruption. However, these indicators are not foolproof. The 1980 eruption of Mount St. Helens caught many off guard, despite extensive monitoring, highlighting the complexity of predicting volcanic behavior. In addition to traditional monitoring, technological advancements are paving the way for innovative prediction methods. Remote sensing technologies, satellite imagery, and artificial intelligence are transforming how scientists monitor volcanic activity. Projects using machine learning algorithms are being developed to analyze vast amounts of geological data, searching for patterns that may indicate an upcoming eruption. While these tools offer hope, they are still in their infancy, and reliance solely on technology could lead to complacency. The interconnectedness of geological systems adds another layer of complexity. Volcanic eruptions can influence other geological events, such as earthquakes or landslides, which complicates prediction efforts. The 2010 eruption of Eyjafjallajökull in Iceland not only disrupted air travel but also triggered significant geological changes, illustrating the far-reaching consequences of a single event. The cascading effects of volcanic activity remind us that the stakes are high and that we must remain vigilant. Furthermore, socioeconomic factors also play a crucial role in preparedness and response. Developing countries often lack the resources necessary for effective monitoring and emergency response, leaving them vulnerable to volcanic threats. Addressing these disparities is essential for creating a comprehensive global response to volcanic eruptions. As climate change exacerbates natural disasters, the possibility of increased volcanic activity becomes a pressing concern. With glaciers melting and geothermal energy increasing, our planet's geology may undergo significant changes, raising the stakes in terms of prediction and preparedness. As we look toward the future, we must balance technological advancements with a deep understanding of geological systems. The quest for accurate volcanic prediction will require collaboration among scientists, communities, and governments worldwide. Embracing this collective effort may help bridge the gap between predictions and reality, ultimately safeguarding humanity against the volcanic threats that lurk beneath the surface. The future remains uncertain, but our resilience and determination can shape a safer path forward. Volcanoes and human civilization have always shared a complex relationship, one that oscillates between affection and fear. These fiery giants can create fertile lands that have supported agriculture and thriving communities for millennia, yet they also pose catastrophic threats that can raze civilizations to the ground in a heartbeat. To understand this connection, let's journey through time and explore the duality of these magnificent yet menacing structures. Consider the ancient civilizations of the Fertile Crescent, where volcanic ash nourished the soil, enabling agriculture to flourish. The eruptions of Mount Hekla in Iceland, for instance, provided rich nutrients to the surrounding land. Similarly, the famous eruption of Mount Vesuvius in 79 AD buried Pompeii, preserving our understanding of Roman life in stunning detail. However, as we marvel at these marvels, we cannot ignore the destruction that follows. The eruption of Mount Tambora in 1815, often cited as the most powerful eruption in recorded history, caused a global temperature drop that led to the year without a summer in 1816. Crop failures resulted in famine, social unrest, and migration, showcasing the fragility of human civilization in the face of such natural disasters. The effects of volcanoes extend beyond immediate destruction. They can disrupt climate patterns, alter ecosystems, and challenge our capacity for resilience. With over 1,500 active volcanoes on Earth, their ability to reshape societies and environments cannot be understated. For example, the eruption of Krakatoa in 1883 not only decimated local communities but also sent shockwaves across the globe, impacting weather patterns for years to come. This chapter will delve deeper into the stories of communities that thrived and those that fell victim to volcanic eruptions. From the Aztecs, who revered the Popocatépetl volcano as a god, to modern cities that exist in the shadows of towering peaks, we will examine how volcanoes shape our societal narratives. In the face of these giants, humanity has shown remarkable resilience, adapting to landscapes forever altered by fire and ash. Moreover, we will explore ongoing research in volcanology and how understanding the relationship between humans and volcanoes can guide future development and disaster preparedness. As we look to the future, it's crucial to recognize that while we can mitigate some risks, the beauty and danger of volcanoes will always be firmly intertwined. What lessons can we learn from our past as we prepare for an uncertain volcanic future? Stay tuned as we explore this intricate dance of destruction and creation, woven into the fabric of human history. When we think about volcanic eruptions, the immediate imagery typically involves lava spewing into the sky and ash clouds darkening the sun. What many may not realize, however, is that volcanic ash poses a significant indirect threat to our modern way of life, particularly in the age of global air travel. In this chapter, we will explore how volcanic ash can disrupt aviation, impact health, and alter economies, all of which can reverberate across the globe. The infamous eruption of Eyjafjallajökull in 2010 provides a compelling case study of the fallout from volcanic activity. When this volcano erupted, it released a massive ash cloud that drifted over Europe, leading to one of the largest air traffic disruptions in history. Over the course of several weeks, thousands of flights were cancelled, leaving millions of passengers stranded and costing the airline industry an estimated $1.7 billion. This incident highlighted how interconnected our world has become and how a single eruption in Iceland can have implications for travel, trade, and tourism across continents. But it's not only the immediate effects of ash that are concerning. Volcanic ash can contain hazardous materials, such as tiny glass shards that can damage aircraft engines. Several near-miss incidents have been reported where planes encountered ash clouds, resulting in engine failure. One notable incident occurred in 1982, when a British Airways flight lost thrust in all 4 engines while flying through ash from Mount Galunggung in Indonesia. Miraculously, the pilots managed to restart the engines and land safely, but the consequences could have been catastrophic. This chapter will dive into the science behind volcanic ash, how it's formed, and its composition. We will discuss the protocols airlines implement to ensure passenger safety during volcanic activity, including flight planning and ash dispersion forecasts. Furthermore, the importance of monitoring volcanoes using satellites and ground sensors to predict eruptions will also be explored. As we investigate the broader implications of ash clouds, we will also look into public health concerns, as inhaling volcanic ash can lead to respiratory issues, especially for vulnerable populations. The 1991 eruption of Mount Pinatubo serves as an example, where ashfall not only affected aviation but also had significant health impacts on nearby communities due to respiratory illnesses caused by ash exposure. In a world so reliant on air travel, understanding the unseen threat of volcanic ash is more critical than ever as we forge ahead into an era of globalization. With increasing travel and trade, how can we better prepare for the next volcanic disruption? What measures can be taken to minimize risks and protect lives? Join us in unraveling this complex web of connections as we examine the profound impacts of volcanic ash on our society and the economy. While many volcanoes around the world are closely monitored, several volcanic hotspots remain enigmatic and underexplored, lurking beneath the Earth's surface like ticking time bombs. These hotspots can generate immense power, representing some of the most dangerous volcanic threats our planet has to offer, with the potential to unleash catastrophic eruptions. In this chapter, we will uncover the hidden threats posed by these volcanic hotspots, their characteristics, and the science behind their formation. One of the most notorious hotspots is the Yellowstone caldera, often referred to as a supervolcano. This area has experienced 3 massive eruptions in the past 2 million years, the last occurring approximately 640,000 years ago. Researchers estimate that a future eruption could have devastating consequences, not only locally but globally, as it could inject ash and gases into the atmosphere, triggering climate change and affecting agriculture worldwide. The prospect of such an event raises pressing questions about preparedness and risk management. Similar hotspots can be found along the Mid-Atlantic Ridge, creating rift valleys and island chains that shift the geologic landscape. These areas serve as a reminder that the Earth's crust is continually evolving, and they are often overlooked in discussions about volcanic threats. The island of Santorini in Greece, for example, is a volcanic hotspot that has experienced catastrophic eruptions, including the Minoan eruption around 1600 BC that significantly impacted the ancient Minoan civilization. Evidence suggests that such eruptions could happen again, rendering coastal cities vulnerable. This chapter will also explore the science of volcanology, focusing on how geoscientists use advanced technologies like ground-penetrating radar and seismic activity detection to monitor these hotspots. What's more, we will look at case studies of volcanic hotspots around the world and their potential impact on surrounding environments. How do researchers approach the daunting task of forecasting potential eruptions? What's being done to assess risk and ensure public safety? Through captivating stories, scientific insights, and expert opinions, we will paint a vivid picture of the dynamic, often forgotten, world of volcanic hotspots. As we continue to expand our understanding of these hidden threats, we must remain vigilant in assessing their potential risks. How prepared can we be for a disaster that, at any moment, could strike from below? Explore this exciting journey with us as we peel back the layers of the Earth's mantle to reveal the mysteries of the ticking time bombs that could change the world forever. Beneath the surface of our planet, vast and intricate systems reveal themselves to be ticking time bombs, hotspots that could erupt with devastating consequences. Hotspots are regions of volcanic activity that occur when molten rock, or magma, rises from deep within the Earth's mantle. Unlike the traditional tectonic plate boundaries that many associate with volcanic eruptions, hotspots can create volcanoes in the middle of tectonic plates. One prominent example of a volcanic hotspot is the infamous Yellowstone caldera in the United States. This massive volcanic system sits atop a hotspot that has caused 3 enormous eruptions over the past 2.1 million years, the last of which occurred approximately 640,000 years ago. Since then, scientists have been unable to predict when the next eruption might occur, leaving an air of suspense hanging over this area, which is visited by millions every year. Using data collected by geologists, researchers have been monitoring the Yellowstone hotspot closely. In recent years, there have been signs of increased geothermal activity, such as ground deformation and changes in hot springs. For instance, the iconic Old Faithful geyser has shown unusual patterns, prompting scientists to reassess the potential threats posed by this supervolcano. In 2021, an alarming discovery was made: a significant increase in the amount of magma beneath Yellowstone. These findings spurred not only academic interest but also concern within local communities and government agencies about evacuation protocols should an eruption become imminent. Studies estimate that an eruption could cover significant portions of the continental U.S. with ash, devastating local economies, agriculture, and even air traffic on a massive scale. Another example of a volcanic hotspot is the Hawaiian Islands, a series of islands formed by volcanic activity as the Pacific Plate moves over a stationary hotspot beneath the Earth's crust. The most active volcano here, Kilauea, has been erupting intermittently for over 30 years, but scientists warn that there is no guarantee against a more cataclysmic eruption. Volcanoes like these remind us that while we can monitor and prepare for eruptions, nature remains unpredictable. The consequences of a major eruption from a hotspot can extend well beyond local destruction. Studies have shown that large eruptions can inject massive quantities of ash and gases into the stratosphere, potentially altering global climate patterns. The 1991 eruption of Mount Pinatubo in the Philippines, for example, caused a drop in global temperatures by about 0.5 degrees Celsius for several years. Imagine if a hotspot eruption were to release comparable or even larger amounts of ash and sulfur into the atmosphere. The implications could lead to food shortages, economic distress, and a potential collapse of societal structures if people are unable to adapt or respond effectively to such a crisis. As we delve deeper into the world of volcanic hotspots, it becomes clear that while these geological marvels are fascinating, they also pose existential risks. What will humanity do when the next ticking time bomb finally erupts, and the consequences extend beyond the immediate vicinity, reshaping our planet and civilization as we know it? The answers lie in our ability to observe, learn, and prepare for these geological giants. Can we move fast enough to mitigate the human cost of nature's fury? Only time will tell, but scientists and communities around the world must remain vigilant.